Hey everybody, good evening. Welcome to week 5. So the topic for tonight, is going to be server architecture. Server architecture. This is a closer look at the design of the audio server in SuperCollider, and this is going to include topics like we're going to revisit out.ar, and we're also going to talk about in.ar. We're going to take a closer look at buses. We already know that 0 and 1 correspond to hardware outputs on a laptop. And we're also going to take a look at the node class, which is actually a superclass of synth. So we have synths, we also have groups, and we're also going to talk about order of execution. So let's do a quick sound check. So get some pink noise. And do a quick chat test here. Cool. Okay, so hope everybody's doing well tonight. Let's actually, before we get into server architecture, as I've been doing the past couple of streams, I just want to correct a few errors that I've seen on some of the homeworks. Cool, thank you, Pierre. Let's start with a synth def. Call this test 0. Let's say sig equals let's do pink noise. Pink noise again. Just gonna whip something up sort of quick here. So in a synth def, we need out.ar. And the first argument we give to out.ar is a bus index, which is an integer. We're going to do 0 here, and then channels array, or the signal that we want to output. So that would be sig in this case. And we're going to close this out and play this. Well, add that, and then synth.new test 0. Right. Let's make that just a little quieter. And this works just fine. Let's bring up the meters. Bring these over here, and we can see that we have signal on 1 and 2. What I have seen people do is this. And I understand why you're doing this. Is because I did this on stream, and maybe I should have been more specific and put a comment here saying, don't do this. And so just to be clear once and for all, when the signal we are outputting is a multi-channel signal, as it is in this case here, we don't want to provide an array. Because what happens, it looks harmless. It looks harmless enough. And you'll notice that channel 1 is a little bit louder than channel 0. And so to see what's going on here, we're going to do s.options.num output bus channels, a little bit of a preview of the topics tonight, and we'll reboot the server, close these level meters, reopen them, and now we have 8 hardware output bus channels, and we'll re-add this synth. And now if we play this synth, we can see what's actually going on here. We have a stereo signal being written to bus 0 and bus 1. So the stereo signal goes on bus 0 and 1, left and right, but it also goes on 1 and 2, left and right. So channel 1 here gets a double dose. I didn't need to add that again, but and if we were to be really ridiculous, to whatever, just do all 3 of those. So this is not the behavior that we intend. So the takeaway here is just provide a number. And SuperCollider handles the rest. It says, okay, I'm going to output this signal to bus 0. And if that signal happens to be a multi-channel signal and contain multiple streams of audio, they just get allocated from beginning to end. So if this were monophonic, take away the exclam 2, then we just have one channel, and we can output this wherever we want. And if this was a 7-channel signal for some strange reason, then we would see this, right? So that is the takeaway. Is that clear? I saw at least a few people putting 0, 1 here. And it looks like a harmless thing to do, but you just want to say the lowest bus that you want, and then you can rest assured that the rest of your signals in your multi-channel signal will be allocated properly. The other thing I was seeing, let's grab a buffer. And I have this prayer bowl. We're going to drop in right here. And let's do PlayBuff.ar. B, I guess we can just do it right here. Right, this is a 1-channel signal. I'm just going to put a 1 here, exclam 2, to make this stereo. And we need the buff num. And so what I assume a lot of people were doing, yeah, be aware of array expansions. Know when you're working with a stereo signal and a mono signal and all that stuff. So for this PlayBuff example, what I assume a lot of people were doing was b.buffnum and saying, oh, okay, you know, let's clear the post window. b.buffnum, oh, it's 0. Okay, so we want to play buffer 0. You know, great, that's fine. And then we'll do done action 2. So there's our struck prayer bowl. And you think, okay, great, next problem. I've solved this one. This is not the smartest thing to do, because you're making the assumption that this buffer will always be given automatically by the server, will automatically be given the buffnum 0. And that's not necessarily the case. Imagine if you were working on a composition and then you're developing your ideas, and then you're like, oh, okay, so now I've got some more sound files here. So new sound file, buffer.read, whatever. And so you load that one, and then you load this one after booting the server, and this one's going to get 0. This one's going to get 1, and then your sound function here no longer plays the correct buffer anymore. You know, just as an example, let me just grab another file here. Do this break drum. So I'm going to just quit the server and boot the server, and it's like we're just setting up for our piece, and we say, okay, we're going to load this buffer, we're going to load that buffer, and now we'll play it. And wait a minute, this is supposed to be our prayer bowl, but it doesn't work anymore. Now we, need buffer number 1. So let's just free all these for a second. Free all the buffers. Let's give these sensible names. Okay, so I've just added these 2 buffers, and we can just check that they're there. Okay, so they're working. And so what we want to do in sound functions is not try to guess, what number might go here. If you have hundreds of buffers, then, you don't want to be keeping track of, okay, let's see, buffnum 67 was the Almglocken, and buffnum 84 was the crash symbol, and that's ridiculous. What you should be doing here, if you're just doing a simple function, function.play, is just say prayerbowl.buffnum. And that guarantees that you get the correct buffnum for the prayer bowl every time, no matter how you load your sound files. As long as you give it a name, you can check its buffnum here at the moment you want to create the sound. I think you can even remove buffnum. And when PlayBuff gets an instance of a buffer for its buff num argument, it says, oh, okay, I guess I just want the buff num of this buffer. So we can just put break drum here. And then if you were making a synth def, you know, if we say synthDef.new, we'll call this simple play. And we'll say var sig equals PlayBuff 1 exclam 2. And here we don't want to hard code anything in here. We just want to say, you know, buff, and we'll declare an argument. We can initialize this to anything. You know, we can't really rely on this default value. We probably want to give it a sensible value like 0 so that it always plays some buffer, you know. And then we say out.ar. Remember, just put a 0 here, because we're using multi-channel expansion to turn this mono sound file into a pair of mono sound files, so effectively duplicating it into a stereo file. And then we want to add this synthDef. And there we go. And now if we do synth.new, simple play, you know, if we just stop here, then what buffer are we going to get? I mean, we'll probably get break drum, because that's the first one. But that's not really the point. The point is we have this the ability to pass in arguments when we create a synth, and so that's exactly what we should do. And I think, yeah, we just leave it like that. So that works. Or we can say prayer bowl. And then here we have all sorts of options, like we can do .choose and say prayer bowl break drum. So that's the other thing I was seeing. I would encourage you to never put a number in for buff num, because then you're basically hardwiring in this value to a synthDef, and you know, even this isn't really a great idea, because then this synthDef can only play the prayer bowl sample. So the correct thing to do is provide a buffer, and then when you call the synth, if you write 2, that's a good question. Let's do that. So the reason it doesn't work is because the first argument to PlayBuff is the number of channels. And this is a value that needs to be known ahead of time. We can't modulate this value. We can't, you know, put a sine wave here and have it, you know, sinusoidally vary the number of channels. Like, can you have 1.5 channels? That doesn't make any sense, right? This is just one of those things that determines the size of the array containing these PlayBuffs. If we put 2 here, it's going to try to sort of, you know, multi-channel expand this, and it's going to be an array of 2 monophonic PlayBuffs, one that plays the left channel, one that plays the right channel. But in this case, you know, here, both of these samples have they're monophonic, right? I think they are both monophonic, right? They have one channel. So we can't put an argument here, even though it seems like that's a logical thing we could do. You know, we'll initialize it to 1. And if we try to add this synthDef, we get this wacky garbage here, non-Boolean in test, whatever. I mean, the problem is that this first argument has to be a fixed value. Number of channels that the buffer will be. This must be a fixed integer. The architecture of the synthDef cannot change after it's compiled. So we have to put a number here. And if we put 2 and then try to play a buffer that is monophonic, it works. We just get 1 channel, and we have this buffer ugen channel mismatch message letting us know that you are not getting what you think you're going to get. We could put 1 here, and then the error message goes away, but we're still only hearing sound in one ear, and personally I find that annoying, so I just multi-channel expand that argument, and that takes care of that. Keep in mind that you don't have to, you know, you can multi-channel expand here. That also works just fine. And you can also multi-channel expand here. That's good too, right? You're just saying, instead of this monophonic PlayBuff, give me an array containing 2 of them. Okay, so the difference between sample.buffnum and buffnum.ir, yeah, okay. They are basically the same. The first one, this here, is what you would consider the language side method for acquiring the buffnum associated with the sample. Buffnum.ir, rake drum, this is going to, what is it? Is that not a, is it lowercase n? Can't be. Hold on, let's look at our list of ugens here. I thought that was a ugen. Maybe it can't be IR. Buffer, info. I don't see that as a class. I'm not sure that exists, but we can still make the point here. Like for example, let's take a look at duration and buff dur. Right. So here, this sample is 0.97 etc. seconds long. Yeah. So buff dur, this returns the an initialization rate instance of the unit generator buff dur. So this is not really usable outside in the language, you know, away from the audio server. This doesn't really give us any meaningful information. This one does. But this is a ugen, so it means we could use it in here. So how can we do this? Let's do buff read, and we'll do so this is 1 exclam 2 buff, and we can get rid of this. We don't need this anymore. This argument num channels. And then the third argument is the phase. So we're going to do line.ar. This is an audio rate pointer that starts at 0, goes to, we could do, the thing to do here is buff dur dot, sorry, this is buff frames.ir, buff -1. Right, the total number, the number of frames in the buffer is the, yeah, the last one has an index of the number of frames -1, and then buff dur.ir buff, and close that out. What did I do wrong? Offline.ar. I need another parenthesis. There we go. Okay. So these are, the difference here is that they are unit generators, and in this case, this is the server method of accessing a certain attribute. So if we were to poll this and play, then we would see this unit generator is accessing the number of samples, which is 556,224. And if we delete that and poll the other one, right? So it is accessing the duration of the buffer provided as its only argument. So in this, 0.97 seconds. And this is useful if you're using one synth but you're going to be swapping out one buffer, one sound file for another while the synth is playing. And in that case, IR is not going to work. But you can do buffFrames.kr, buffdur.kr. And so this is actually constantly getting a new value at the control rate. And if buff doesn't change, it's always going to have the same value. But, we could then, if we were to do x equals synth.set, we can say buff a different one, buff num, right? And then we would switch to a different buffer. Maybe if this was like looping somehow, we were using a looping method, then we could switch the buffer out, and these values would update correctly. It would change to the number of frames in the new buffer and the duration of the new buffer. IR wouldn't work that way. So that's fixed. And so if you anticipate changing the buffer you're using, you want to use control rate. But your original question, which is what's the difference here, this is how we access the value in the language, in the language side, as we're just writing code and getting values. This is how we access the value on the server. We could do it this way, but this is kind of like you're always going to be doing IR with this line of code. There's no way to continuously check with this one. Okay. Yeah, it's kind of a long explanation. Sorry. We should get down to business here. So let's whoosh, away everything goes. Let's talk about server architecture. And I want to start with an example of something you might run into, a problem that would be a reason to learn about the architecture of the server a little bit more closely. So let's make assign ask, say frequency, initialize it to 1 kilohertz, and let's make an envelope and we will make a sort of 0, 1, 0 levels. We'll do a quick attack and a semi-quick release, curve up, curve down, and I'm not going to do done action 2. Instead, I'm going to do, for the gate argument, or the trigger, the thing that triggers this envelope, we'll do a lfsaw.kr. And this will have a frequency of 0.5. So every 2 seconds, we'll get a non-positive to positive transition, and that will serve as a trigger to restart this envelope. And we will also scale this down a little bit. And let's stop there. See, did I mess anything up? Doesn't look like it. Oh, let's make it stereo. Yeah. Very simple, right? And let's say we want to put some reverb on this synth. Well, we can go, a very logical seeming thing to do is to go here and say sig equals sig plus gverb sig. And we'll say room size 200, reverb time 5. And because we're summing 2 signals together, actually, let's, maybe let's make the reverb, a bit quieter. And then, yeah, we'll turn it down a little bit more. This should be fine. Oh, yes, definitely. Here's the node tree. And you know what I'm going to do? I'm going to just quickly change this back to 2 output channels. And then quit and reboot. And just gives us a little bit more real estate on our, yeah, hopefully that's good. That's kind of small. Okay, so what we're doing here is we're modifying our synth to, after creating a sine wave and applying a looping envelope, basically a looping envelope, we are going to scale it down, make it stereo, and then sum it with a reverberant copy of itself. And let's take away this. Here we go. Ah. So nothing seems out of order here, right? We've got some lovely tones. Why don't we make freak xbrand 300 2000. This will be nice. Oh, uh-oh. That's not good. Okay, let's see if I can. Come on, computer. Oh. Come on, we talked about this, computer. This was all part of the plan. Oh, it won't let me. Okay, patience. Patience. Come on, turn blue. Oh. Come on. Okay, please. Okay, I've lost patience. We're doing it that way. Yes. Okay. So let's talk about what just happened. Okay, we need to server kill all here. Okay. And node tree. All right. So every time we ran this line here, line 16, we made a new synth. And we basically put this little, let's make it here. We made a synth. Here it is, right, on the node tree, this little white rectangle in the middle. And it contains a bunch of unit generators that are interconnected. And gverb is a reverb UGen, and so as part of its design, it contains a whole bunch of delay lines, and it has to allocate memory space for those delay lines, and so it's not exactly the cheapest unit generator in the world. And so every time we make a new synth, we actually create another synth from the same synth-def. So this is another Synosc, another envgen, another LF saw, another gverb, and we could keep going. And every time we do this, the server has to allocate more memory for another gverb and another gverb, and eventually it just runs out of memory that it is allowed to dynamically allocate, and it says memory allocation failed, and we get this sort of Stack Overflow-esque outpouring of messages, and everything locks up, and so it's you can make a comparison to the running a DAW on like a a computer from like 2005 or something, and you have like 30 or 40 tracks, and you're working on this complex gesture, and each track has its own reverb insert plugin, and after a while you'll start to drop samples, or you'll get error messages, anyway, it's just sort of not the way to design a synthesis network. If you want a reverb effect and you want them all to have all the sounds to have the same reverb quality to them, then you just make one reverb and you send all of the sound sources through that reverb. So one really quick and dirty and really not correct solution here is to change the server options attribute mem size, which is the number of kilobytes of dynamic memory SuperCollider is allowed to allocate. And right now it's set to 8,192. So I will sometimes set this equal to a value that I usually default to is 2 to the power of 20. I've never had any problems with this value. So then if we quit and reboot the server, we can see that mem size is now a lot bigger, and now and we can kind of a lot more safely make all these synths. But this is not really the most elegant solution, and in fact I would go so far as to say this is the wrong solution, because one thing we still can't do is to stop the sine waves and let the reverb continue to decay, right? Everything is hard-coded together into one synth def. So when we play a synth, all of this is running and it's connected. We can't stop the sine waves without also stopping the reverb. The best we can do is say, s.free all. And then, wah-wah, there goes our reverb. So it's not a very, suave way to end our little etude here. So this is why server architecture is important. What we're going to talk about here is all the terminology and stuff in order to create multiple synth defs, some of which are responsible for generating signal and sending it out, but not necessarily straight to the hardware. Instead, sending it to some other bus and then creating a synth def which has the corresponding unit generator in.ar. And that is going to be listening to the bus. And so it receives the signal generated from the first synth and processes it, and then this synth def will send it out. So so we're gonna get into the weeds a little bit here with sort of how everything is all working together and how we can create complex and sophisticated signal flow. Wah wah, exactly. I hope you guys are enjoying your pizza or your barbecue or whatever it is that you got. Sounds delicious, whatever it is. All right. So there are a couple of ideas. Your SuperCollider is down. Like you can't boot the server. Have you tried server.kill all? Yeah, so if you can't boot the server, I would try server.kill all and then s.boot. It should come up. If you try to boot the server and it gives you like a sample rate mismatch error, then you probably need to go into audio MIDI setup and make sure that your sample rate is consistent with whatever. Come on, cannot type today. You want those rates to be the same? Yeah, did you do the thing that I just did where you make a whole bunch of G-verbs? Yeah, so if you're getting that, you just need to sort of Command-Alt escape and force quit SuperCollider, and then just open it back up and server.kill all. I think that's, if that's what you're talking about, if you got a bunch of memory allocation failed. Yeah, just force quit it and start it back up. Okay. I think we can probably keep this synth def. It might be useful, but let's cut the reverb out. Right, so we're gonna cut that reverb out, and so we've still got our sound, and we want to apply reverb to this, but not in the same synth def. Okay, so I'm gonna make a second synth def here. We're gonna say synth def. Let's call this just tone, shall we? Tone. We'll call this. We'll change that to tone. Synth def.new reverb. All right. So var sig equals. No, it's not a feedback loop. Do you mean is what like a feedback loop? Is the memory allocation failure messages like a feedback loop? Okay, so we're going to do sig equals in.ar. Okay, so this is the corresponding, it's sort of the other side of the coin. We have an out UGen for writing a signal out. Yeah, so the memory allocation failure messages, it's just that there's only so much memory SuperCollider is allowed to dynamically allocate when you make things like delay lines or things which require like, dynamic allocation of buffers. And if it runs out, if it exceeds the amount that it's initially allotted, then it just says memory allocation failed. But if that failure occurs in the process of a UGen, which is continuously generating samples, it continuously needs to access that buffer space or that memory in order to make sound. And so you see the message again and again and again and again. And you just get a ton of messages, and then all these screen updates cost a lot of CPU cycles. So that's why everything becomes sluggish. So it's not really a feedback loop. It's just like SuperCollider ran out of memory, and it continually needs memory, so it just keeps saying, I need memory, I ran out of space, I ran out of space, I ran out of space. Okay, so in.ar needs two things. It's similar to out.ar. We need to provide a bus, and we need to provide the number of channels. Okay, so first things first, instead of just playing this to 0, we're going to make an argument. We're going to make an argument called out. We'll initialize it to 0. So in this case, we still get our signal going to 0. So we hear it in the speakers. And I'm also going to make this monophonic. So now we just have a monophonic signal, Okay, nothing new so far. All we've done is declare an argument so that we can, if we wanted, specify a different output bus. Right, so now it's over there. Now it's over here. And we can send this anywhere we like, even bus 47. Ready? Here we go. It's playing. It's playing to bus 47, wherever that happens to be, right? Okay, let's free all this for a second. So we're going to do something similar with in.ar. We're going to also declare a bus called, not a bus, we're going to declare an argument called in. Arg in. We will initialize this to 0. This is sort of like buffer arguments. The default values are generally not going to be something you want to rely on. It's something you want to specify when you create the synth, okay? And then in also needs to know the number of channels. So we need to know, as programmers, as users, what kind of signal is this UGen going to be receiving? And we're going to send this tone, the signal generated by this tone synthDef, to the reverb synthDef, and this is a monophonic signal, right? Nowhere do we see any array duplication. It's not going through a pan 2 or anything like that. It's monophonic. So we provide 1. Sig equals in.ar. All right, then we theoretically have our signal, which we have read in from the bus with the index provided by this argument. And so then we can do something like sig equals sig plus gverb.ar sig 200, 5, and right? Well, what did we do? We multiplied this by 0.2 or something, just so that the reverb is not equally loud. We want the reverb to be made a little bit quieter, so it sounds kind of realistic. And then out.ar. And just to be consistent, we'll also make another argument here. Okay, glad it's working, Dungrul. You killed all the servers. That's the way to do it. Okay, and so we need to say out equals 0. Again, don't worry too much about these default values. Just realize that you are going to need to specify exactly what you want. It's just a good habit to get into. Okay, and let's actually put these in the same clump of code. Right, so now we have 2 synthDefs. That looks good. All right, so everybody with me so far? This is gonna get pretty cool. So let's say reverb synth equals synth.new reverb. And what we're going to do here is provide arguments. Now, this synthDef has 2 arguments. We want it to read from a bus that's going to have some source signal on it. Arbitrarily, I'm going to say 40. Sorry, we don't put 40 there. We say in 40. And out, where do we want this signal to be written to? Well, this is, we don't have any other effects or anything. So once we get our source signal into our reverb synth, we're ready to pass it out to the speakers. So we can just say out 0. All right. And then tone synth, tone, and this has 2 arguments, the frequency of the tone and the output bus. So for frequency, we will keep our xbrand here. Let's clear some of this stuff. And out, where does this go? Well, it goes to bus 40. So before we run this, let's take a look at what we're doing. We're making a reverb synth. Here's our node tree. And there we go. And you can see that we actually have our reverb synth right there. And then we will make our tone synth. And that is your first taste of the magic of server architecture. We have 2 synths, tone, which is generating a tone and outputting to bus 40, which of course we don't see it anywhere here. You know, bus 40 is way over here somewhere. And our reverb synth is listening on bus 40. The default is 0, but when we create the synth, we say your input bus is index 40, and we're sending it out to the speakers. One question which might come up is, why are we seeing two signals here? You know, this is a one-channel bus, monophonic here, and we have sig plus gverb. The answer is that gverb actually outputs a stereo signal, regardless of whether it receives a mono signal or a stereo signal. So gverb, like pan 2, for example, outputs a stereo signal. It's a little inconsistent in that way, in that it's sort of different from a lot of other unit generators. So now the first cool thing we can do is we can say tone synth dot free, and as I do this, listen to the reverb. So it decays very nicely, and in fact, the reverb synth is still running. So we could create our tone synth again. All right, we can make another one. Well, actually I screwed that up because now I can only access one of them. So I embarrassingly have to do s.free all here. You know, so we can make our reverb synth, and we'll say tone synth 0, tone synth 1. And then we can sort of free them all individually, like this. Okay, so I see some questions here. Are there default values for what we should put as the input channel? Yeah, it's a tough call. I mean, you could set it to be some high value somewhere, just so it's not accidentally reading something it's not supposed to. I think you should just always make sure that if you prefer, you can just not initialize it, and then it's nil or something, so it probably somehow translates to 0. I don't really know. I've always just sort of either provided a 0 or nothing, knowing that when I call this synth, I am going to give it an explicit buff number, or not buff number, a bus number. Can you open the stethoscope at channel 40? I do not think you can. Maybe you can. Actually, that's a good question. Okay, so it may be limited to the number of output bus channels, which is 2. So you can really. So if I do this again, and then s.scope, and then one channel forward is L. So there's, I should have been counting. Let me start again. Okay. Okay, so we're now looking at 2, 3, 4, 5, 6, 7, 8. Oh, there's a number box on this thing. Oh my god! Look at that! You can! Yeah, you just change this, right? You can. So these are our output channels. I did not know you could do this. Right, so there's our reverb, all that tail there. But we can look at channel 40, and it's our sine wave without the reverb. That is cool. I didn't know you could actually. I thought it was just going to be however many output bus channels you had. Neat. Oh, we have 2 reverbs now. That's not what we wanted. Okay. So that's the most primitive way that you can do this. It is not at all the most elegant way. There's so many improvements we can make here, but I just wanted to start at the the sort of most basic thing here. So, yeah, sorry, the reverb input, right? It's the sine wave output, however you want to think of it. All right. So as you might be thinking, it's stupid to use numbers here because let's imagine we have a reverb effect, a different reverb effect, a delay effect, and then like maybe 7 other delay effects with different delay times and maybe some filters. And you do not want to be having to, okay, let's see, the high pass filter was output bus 87, and the third delay was output bus 4012, and I mean, that's just horrible. I mean, so anyway, it's for that reason that there exists a class called bus, which is the language side representation of an audio or a control bus on the server. So we'll get into this. Let's talk a little bit about buses on the server. So we know that we can say s.options.num output bus channels. This is currently 2. We can change this to something else. Let's change it to 4, and s.options.num input bus channels. Well, that's 2. We'll leave it at 2, and then we'll reboot the server. See a question. Why will this not work if you run them in the reverse order? I'm going to get to that. Is bus 40 not there for the reverb to listen to until it's created when we pass it? That might be accurate. I'm not exactly sure, but yeah, we will get to that. That is the topic of order of execution. Okay, so right now we've rebooted the server just to change a few values. So now we actually have 4 output buses, which are sort of designated as hardware output buses. There's another line you can evaluate here, s.options.num audio bus channels. And this by default is equal to, oh, okay, I see. It's 118. Yeah. Let me, it's not what I was expecting, but that's okay. So we have, this is the number of remaining, I think, audio bus channels. Actually, just to be safe, I'm gonna quit and reopen SuperCollider. Just let's start that one more time. Okay, boot the server, run this, and let's just forget about this for a second. Num audio bus channels. Yeah, that's what I was expecting. Why was it 118? Something weird happened. Okay, so this is the total number of audio buses, not hardware audio buses, but just audio buses that are available. And the lowest numbers of these 1,024 buses are reserved for num output bus channels. So of these 1,024 buses, right, here is 0 and here's 1. And the next lowest, another 2, are reserved for inputs. So technically this is audio bus 2 and this is audio bus 3. And the remaining buses, 4 through 1023, are reserved as so-called private buses, explicitly there for the purpose of doing stuff like this, passing audio signals from one synth to another, where they won't go to hardware, they'll just be internal to SuperCollider. And and as I was saying, it's really, why would you pick 40 instead of 30, instead of 22, instead of 79? So it's the correct thing to do here is to, if you have an effect synth and you're gonna be sending signal to it, you should make a bus, and we'll call it reverb bus equals bus, and then the bus class here, there's two class methods that you generally use, control or audio. And in this case, we are outputting an audio signal. So we're going to use bus.audio. And bus.audio needs the server on which this bus will live and the number of channels. So we'll say bus.audio S1. And there we go. And notice in the post window here, we have two hardware input buses and two hardware output buses. And those have indices 0, 1 for outputs, 2, 3 for inputs. And so 4 is the first available private bus. And so that's exactly what happens here. We have created an audio bus with index 4, 1 channel, and it's on the localhost server. And so the bus.audio, the bus class basically takes care of allocating for you. So now, well, we have our synth defs here. We are going to say in reverb bus and out reverb bus, right? So here's our reverb synth. And here's our tone synth. Okay. Oh, what am I doing? Free. Okay, and we'll also free the reverb synth. So this is cleaner. This at the beginning of your code, this kind of thing here, you would probably put this, here. So this is that we allocate a bus on the server, and the bus class knows how many hardware outputs and inputs we have, and it says, okay, I'm just going to take the first available one. And so, for example, let's say we also had a delay effect, like sort of an echo or something, or we could say, echo bus. And let's make this also 1 channel. And notice it knows that it already allocated a bus. So 4 is no longer available. That's, reserved. So it grabs the next one, 5. And if this reverb bus had been a stereo bus, if this had been a 2 instead of the 1, then we would see a 6 here, which it brings up a good point, which is that there's no such thing as a multi-channel bus in SuperCollider. All buses are 1 channel, but when you allocate a stereo bus, it takes the lowest available bus and also takes the one right after it. So, for example, now if we were to say, let's grab a stereo bus, and this is going to be 2 channels. It gets 6, but it's actually 2 channels. So if we were to get yet another stereo bus 2, yeah, see now we take 8. Okay. And if you want to restart your bus allocation, you say s.new bus allocators. And now, as you can see, we start back at 4, 5, 6, 8. Right. Right. And these are just the server just sort of sees these as indices. It has these audio buses it can use, and it just says, okay, that one, that one, that one. It just sort of numbers them. So there's nothing too fancy going on here. So we'll get rid of these and run this code again. Why not? And so now we have a reverb bus, right? It's a bus. It's an audio bus, so we can do stuff like this. Okay. So that's lesson 2, right? It's just use the bus class to your advantage, and just let the bus allocation process take care of that for you. So you can give your buses meaningful names, and then when you actually call your synths, it's very clear. What's the input to this synth? Oh, it's whatever's being written to the reverb bus. And what's the output of this synth? Well, it's going to the reverb bus. So it's just makes everything much more readable. Okay, so now I'm going to get to Jake's question here. And this is something that you would very, very easily run into. I'm going to just evaluate these in the wrong order. So here we go, tone synth and reverb synth. and we get silence. We get absolute silence. Let's free these. And just to demonstrate that nothing, that we didn't lose the server or anything like that. If we run the reverb first and then tone synth, everything works. And you'll notice that you can see tone is at the top here and reverb is below it. Okay? If we do this in the wrong order, tone first, then the effect, we get nothing. Reverb and tone, right? So this is order of execution. There is, as Pierre pointed out, order of execution. And this is the paragraph that I show on tutorial 7. The rule is simple. If you have a synth on the server, in other words, an effect that depends on the output from another synth, the source, the effect must appear later in the chain of nodes on the server than the source. So when we create the reverb first and the tone synth, then the source is at the top and the effect is at the bottom. And that's what we want. Now the reason it fails the other way around is, let's see, so I'm going to keep these here. Yeah, I'll look at, we'll look at them here. The reason this fails is because SuperCollider, like I think every piece of digital audio software, processes audio in blocks of samples. And in many different types of audio software, you have effects, which means a signal being passed from one synth to the next. And each control cycle, when the program needs to calculate the next block of samples to go to your hardware device, your audio interface or your headphones or whatever, your laptop sound card, it needs to start at the beginning. And if some signal is writing to a bus, then it says, okay, so now these samples are on this bus. And then it moves to the effects, which read from a bus. And then those samples have been written there. So it says, okay, I'm going to take those samples, and then I'm going to process them in this effect. Now, if you have it the other way around, so that the effect is at the top and the source is at the bottom, even if they are sharing the same bus, writing to the bus, here's what happens. The server needs to process a block of samples. So it starts at the top and it says, okay, reverb. I'm going to read from this bus, which at that moment in time is empty. It just contains zeros. And then it says, okay, this reverb goes out to bus 0. So it writes zeros to the speakers and to the level meters. So that's why we see nothing on the level meters. And then it moves down the node tree and it says, okay, I have another synth, which is, producing this sine wave, and it's outputting to, this reverb bus, bus 6 or whatever. And so it writes the sine wave to bus 6, the reverb bus, but the process of reading that bus has already happened. So those samples never actually get read and never make it to the speakers. So, and then at the end of one control cycle, what does SuperCollider do? It wipes all the buses clean. It zeroes them all out and then starts on the next control cycle and the next 64 samples and the next 64 samples. And if these nodes are in the wrong order, then it reads samples from a bus and then writes them. And that's not the right order because you have 0, it reads that to hardware, and then it writes actual sound to the bus and then clears everything. So that's why it doesn't work. Now, the question of why this particular order, that's something else we're going to get into. And so do take a look at this order of execution help file and just read, sort of the first paragraph or two or something, just, at least the first 3 paragraphs, just to get a sense of what's going on here. But the golden rule is head to tail. And when we say head to tail, that means the head of the default group, or just the node tree, that the top to bottom, these local inputs, that's a result of the meters being open. So we can just close that. This is the node tree. This is a picture of all the nodes, which are synths and also groups, which we'll get to in a bit. And the stuff at the top gets processed first. And so those are all the sources that need to go go out to effects, and the effects all need to be last. So if you have a sine wave going to an echo, going to a reverb, going to hardware, it needs to go sine wave, echo, reverb. And so you need to make sure those nodes get put on the node tree in the right order. Okay, so we've been talking about nodes. We've been talking about nodes a lot. Let's talk about nodes more formally here. Okay, so node. What is a node? Node is an abstract superclass of synth and group. So we never actually use the node class explicitly. And I think it says that here. Node objects are not made explicitly, but synth and group are subclasses and inherit the methods documented below. So as a user, we would never do something like n equals node.new, whatever. You know, we'd never do that. Node is just there to provide infrastructure and methods and definition for its two subclasses, synth, which we know fairly well at this point, and group. Okay, so let's talk about synths and groups. Now we know what a synth is. Let's open the node tree. In fact, we're gonna give ourselves some luxurious room here. Close this, close that, and let's see. We'll put this here. It's a little crammed here, but you know what? We'll make do. Maybe we'll detach and close that and come back to it if we want it. So we we make this reverb synth. We make this tone synth. Let's turn, let's say sig times 0.2 again. So now this is going to be quieter so we can sort of hear ourselves think. So here we have two synths, and we're also going to make a group.new. And let's just watch what happens. Right? We have made our first group. It's right here. We can make, let's say g.free, and watch the node tree here. There it goes. It's gone. Right? There's a group. There it goes. So free is a method that's actually defined for the node class, and synth and group both inherit that method. So let's say G0, G1, and G2. So we can make these groups, and then we can free them. And you'll notice, you might notice that these synths, these two synths here, are actually sitting inside of another group, this larger gray rectangle here, which is the default group. And when you boot the server, in the background, this default group is created for you automatically in order to have a place to put these synths. Okay, I'm going to command period here. All right. The main purpose of groups is to, can you change the default group? You can talk to it. You can access it. It's s.defaultGroup, I think. Yeah, so s.defaultGroup gives us this group here. You mean, can you like make another group and set that one to be the default group? Probably. You probably can. But I don't think there's ever any reason to. The default group is there so that when you add a node to the server, but don't specify where specifically it's supposed to go, you know, at the head or the tail or somewhere in between, it says, okay, I'm putting it on the server. It needs to go in a group somewhere, so I'm going to put it in the default group. So, you know, technically you can free the default group, and now it's gone. So now we actually have nothing. And in this case, like I think nothing will work here. Yeah, so we can't make synths anymore because there's no default group. So command period will fix this because that sort of clears everything and reinitializes the node tree, and so we get our group back. Yeah. Okay. So what we know is that tone synth has to go above reverb synth. And so we are going to revisit the synth help file. And we have been creating synths quite a bit. And we know that the first thing the synth needs is the name of a synth def. And then it needs an array of arguments, especially if we want to provide values other than the default values. And then there are two additional arguments, target and add action. So target is, it's basically an existing node on the server. So for this, you would specify an existing group or an existing synth, some sort of node. But you can also provide the name of a server, in which case the target becomes the default group of that server. And you can also say nil, which defaults to the default group of the default server. So I think by default, what is the default? Not actually sure. It might be the default server. So, and then add action. Hang on. Add action is a symbol which specifies the placement on the node tree relative to the target. So add to head, for example, adds the node to the head of the target group, for example. Add to tail adds it to the tail or the bottom of the target group, or whatever the target happens to be. Add after and add before. This allows you to add a node immediately after an existing one or before. You can also replace an existing node. So one way to make sure that these synths end up in the right order is, let's actually space these out a little bit, just to give ourselves a little bit more room here. Oops. Okay. Yeah, I'm sort of indecisive about the white spacing of my synth.new calls sometimes. Okay, so tone, let's actually specify a target. We can say S for the localhost server, right? And this is going to get put in the default group, right? And we'll say, add to head, right? So, whoops. So seems normal. Of course, we're not going to hear anything, but what we could do, I guess, to actually hear it, is specify out 0. Right? There it is. I want to make that just a little bit louder. What I should do is put an amplitude argument here. Yeah. Okay. So, and then we would go to our reverb synth and set its input and its output. And now here, one example is we can say the target for the reverb synth is the tone synth. And the add action is, well, I'm going to let you figure this out. So we create the tone synth. That didn't work because, okay. Where's my, yeah. And now what we want to do is add the reverb synth. Yes, Pierre is onto something here. That's usually what I do. But first we're going to do this. So we're going to make the reverb synth, and we need to, its target is this existing tone synth. So what kind of add action would be appropriate in this case? Here's our add actions. Add to head, add to tail, add after, add before, add replace. Which one should we do? Tail. I think that would work. One thing we do have to keep in mind, though, is that the tone synth is currently playing to output bus 0. So we can make this. And, it actually says group not found. So add to tail only works if this is a group. So we could say s, or s.default group, add to tail. And that works, right? Because now the target in this case is the default group. And it says go to the tail of that group, or the end of that group. And then all we have to do now is tone synth.set out reverb bus. Tone synth 0, excuse me. And there we go. Okay, so let's back up a little bit. Let's clear some of these. Let's bring this down a little bit. And then reverb synth.free. Right, so we made our tone synth. And this time let's send it to the correct bus. All right, so there it is. And this is one option for creating the reverb synth second, to make sure it goes in the right place. It just has to be after this tone synth somewhere. No, this is independent of buses. See, as you can see, they are reading and writing to the same bus, so that's all fine. But they also have to be in the correct order on the node tree. Okay. So so we'll say s.default group again, and we're going to say add to head. And see, we've put it at the head of this group, and that doesn't work because now it's before the tone synth, so it doesn't work. So we're going to free that, and we can say add to tail. And that is effective, okay? Another option is we can set the target to be an existing synth, tone synth 0. And in this case, we want to say add after. So this tells the synth, add yourself immediately after this existing node. And that also works. Right? We could even do something, I mean, this is a little bit weird, but just to show you that it does work, we can say s.default group and then add after. So we have our tone synth. So I want you to take a moment and try to imagine where this is going to appear on the node tree here. So we are making a reverb synth. Its target is the default group. That's this. And the add action is add after. Oh, I don't have an uptime command. I guess I could add one, but I've been streaming since 8 p.m., which is about 75 minutes ago. So somebody try to make a guess here. When we run this code here, where are we going to see our little white reverb rectangle? Also, hey Beal, how you doing? So let me know what you think. Okay, I'm going to do this. It's going to go after the default group. And it works. Because everything is in an order. It doesn't actually have to be inside this group, this default group. It can be after the group, that's acceptable. As long as it is after the tone synth, the source of the sound, then it will work. So if we were to do add before, well, there it is. And it's outside the default group, and it doesn't work because it is before the tone synth. Cool. Good to hear it, Beetle. All right. So these are the various methods we have. You know, we could also make the reverb synth first and just ignore all of its targets. Oops. Let's clear all those. So there's our reverb synth. And now, actually, this is sort of the more standard thing to do, is establish all of your effects so that they're all running and active and waiting for signal, but no actual source yet. And then we can say, you know, we're going to add this. The target to the tone synth is going to be the reverb synth, and an add action. In this case, what's an acceptable add action here? Again, let's bring up the help file. What kind of add action would we want to put here? We're adding the tone synth. We already have our effect before. Add before. Exactly. So, yeah, bingo. Now, the other thing we can do is actually use groups to our advantage. So let's make some space here. And what we're going to do is say source group equals group.new. And then for group, there's a method after and before. So actually, when you create groups, you can say something like, hold on. Let's put this back in, shall we? Doc. So we can say effects group, and this is equal to a new group dot after source group. Okay, so we could run these, and now watch the node tree here. Kapow! There we go. We have created 2 groups. They don't make sound, but they are nodes. And these are here to guarantee a specific order. So now all we have to do is just make sure that the target for each of these synths is appropriate. We don't even have to worry about add actions anymore. All we have to do is set the target of the tone synth to be source group. And we just set the target of the reverb synth to be effects group. And now, look at that. So we can just, as long as we put it in the correct group, it is guaranteed to be in the correct order because the source group is before the effects group. And in fact, I think you can even run all of these at the same time. And I am 99% sure that this will always work. How cool is that, right? And so, it gets even cooler. So we don't even need to give these synths names anymore, actually. We just need to give the groups names. So we're gonna run this again. And maybe our composition is rolling along and then we want to have another event or maybe a button on our MIDI controller that adds a new synth. So yeah. Just gonna clean up a little bit here. Right? Now how do we get rid of these, right? Okay, we didn't give them names, right? We didn't say, x equals or 10.collect or anything like that. So how do we refer to them? Well, we are kind of limited. We can't refer to them individually, but we can refer to the group. And we can, groups, just like synths, inherit their methods from node, and the set message works here. So we are actually setting a group here. And we can set, for example, all of their outputs to be 0. So this message is going to this group here. And when a group receives a set message, what happens is that message propagates inwards to all of the nodes inside that group, whether they're synths or groups. So if they're synths, they receive the set message. And if they are groups, they, again, propagate that message inward, and they send it to all their inside things. So here, watch this. So all of a sudden, we have routed all of the synths inside the group straight to hardware, and we can route them back to the reverb bus. We can add more. And of course, we're not making any more G-verbs, right? We only have one G-verb. So we have this single reverb sitting there, just one G-verb AR, processing all of these signals that come in. Just like this is the same as having, you know, an outboard effect racked into your studio, and you can just use your mixer's auxiliary sends to send everything over there. And yeah, so we can also say source group dot, not free, but free all. Free all is a different message that only applies to groups. So when a group, like this one, receives a free all message, what it does is it sends the free message to everything inside of it. So watch. All those nodes go away, and we still get our lovely reverb because that's in a separate group, which we are not messing with. Right? So we can add more, and we can free all. Note that we can source group dot free. So let's say we do this. Well, I like that one. That's good. Now, instead of free all, let's do free. And what this is going to do is actually free the group itself, and everything inside of it also gets freed. So, you know, we still get a nice, lovely reverb decay, but now if we try to add more synths, node not found, right? This source group has been freed, so it no longer exists. It's the same reason we can't set a synth that has had a done action 2 get executed, because then it frees itself. It goes away, and we can't talk to it anymore. So we would need to do source group.new, and the default add action for synths and groups is add to head. So if we just make a new group, it's going to add it to the head of the default group. So that's fine. But we could also do, you know, if we free it again, you know, we might want to say group dot, you know, actually I'll do it down here, you know, source group equals group dot before fx group, right? And that also guarantees that it's up there. Okay, so nparmar, since we only have one reverb, do we ever have to worry about the reverb getting 2 signals at once? Oh yeah, it's getting, I mean, it's all these signals that are being written to, you know, this bus, reverb bus, they're just being summed together. Let's say 2 sine waves happen to be generated at the exact same time. Well, when they're written to the bus, remember, they're just digital audio samples, which are just floating point numbers. So they will sum together, and you will get the sum of those 2 waves. And that signal gets sent to the reverb bus, or gets written to the reverb bus and read by the reverb effect. And so it's the same thing when we just add 2 sine waves, like in a standalone synth def. We do have to make sure that the signal doesn't exceed 1, you know, because then it would clip, and, you know, probably the reverb would clip it too. So you do want to manage your levels, but yeah, it's not like you have to have only 1 signal at a time. You can send 1,000 signals to one bus, and they'll just sum together. So it's really quite handy. And Pierre is saying, okay, so I guess this could be used, for example, setting a filter frequency on a polyphonic synth, provided. Yeah, you could do the same thing. In fact, yeah, we could do that. I don't know, maybe that would be a little bit too much of a gear shift there, but if for example, instead of this reverb synth, imagine we had a filter synth, right? We were sending all these crazy sound files to it, and they were all going through a low pass filter. You could just send a message to this one reverb, one filter effect, and we'd adjust the cut. In fact, you know what? We're here. Why don't we spend some time here? Let's say reverb time equals 5. Right? Reverb time. So we have added an argument to our reverb synth. And so now we'll just go ahead and do this. Maybe add a few more. And we could talk to the reverb synth itself, because we did bother. No, actually, no, we can't, because we didn't give it a name. This synth here. Oh, something's. Okay, hang on. Let's start over. There we go. Yeah, if you run this again, then you will make another group and overwrite that. You do make another group, but then you're using this global variable to talk to that new one, and the old one is inaccessible. So you don't want to run this again. You want to command period first. Something like s.freeAll. Yeah. So we free everything and then reinitialize. That's probably a good idea. So make a few more. So we can talk to the we can't talk to the reverb synth because this synth here has no name language side, but it is in a group that has a name. So we can say fx group.set reverb time 1. And I think that worked. I think. Yeah, let's make this a little bit louder so that we can actually hear everything. Let's make that 0.5 and this a little bit louder. Okay, so we'll start over. Yeah, so we've got a 5-second decay. We'll change it to a 0.1 second decay. That doesn't sound like 0.1 seconds to me. Tell you what, we're going to make some quick changes here. saw.ar. And we're going to send this to okay, see, I mean, I figured it's working. I'm just not hearing enough of a change to sort of be convinced. So we'll do a resonant low pass filter. Input is sig. We'll change this to cutoff frequency and set it to 1000 to start with. And we're going to say cutoff frequency. We'll have a quality of 0.2. Yeah. Okay, so now hopefully I didn't screw anything up. Yeah. And oh, okay, we need to make the stereo now because we'll just do that, and we'll take away that. Okay. Yeah. So let's make a bunch of these. This sounds less cool with reverb, but we can change the cutoff frequency. Let's at least round these to something nice. Let's okay. Oh, let's take this away. Yeah, okay. So there we go. We have our two groups and just our, it's called reverb. Let's change the name. Low pass filter and low pass filter. Okay, so now it's called low pass filter. So I can sleep at night. All right. I just can't, I'm sorry, this sounds so stupid, but we can see that it's working, right? So we have this effect group, which has a single synth, and if we set the group, that set message gets passed in. So basically this gives us a way to filter tons of synths at once. As long as we send them through the same filter, then we have access to, yeah. And then we will free all from the source group. There they go. Oh, I like that reverb. Well, that's okay. So I've covered a lot of things. There's, I think the last thing I kind of want to do is show you how you would do a true auxiliary send. And here's what we're going to do. Reverb again, and we'll bring back our Gverb because I need that Gverb. Plus reverb.ar sig 200 5. We can get rid of this cutoff frequency times 0.3 sig times 0.5. This should be okay, right? And change this to reverb, and should be good. Yeah. Yeah. I don't know why I stopped that. Okay. Okay, so the way we would do a true auxiliary send, let's think about a mixer, for example. You have some input channel strip and it's got some signal on it. In this case, it's got a bunch of saw blips. And you have multiple places you can send that signal. So in other words, you have multiple outputs. You have your primary outputs, you know, with your main left-right fader, but you also have auxiliary output knobs, you know, that you can send that signal to an additional output. So the way we would do that is we would make another out. We'll call this aux out, and we're also going to send out the same signal. So now we need to, we'll say, you know, aux out and out. And you know, we might as well provide ourselves with aux amp, right? What is the amplitude of the auxiliary send? So set these both to 0. Aux amp equals, we'll initialize it to 0 so that, you know, the send knob, so to speak, is down all the way. So we're just sending zeros to the auxiliary output. So that is working. And right, so now, okay, that's all good. We've got our reverb bus, and we've modified our input source, which we can think of as a you know, one channel on a mixer, and we've modified it so that we can now send it out to 2 different places, this bus and that bus. And this one is going to be listening to the aux out bus. And now we do not need to mix between the dry and wet signals anymore, because the dry can go straight to the hardware, straight to our ears. And then we can send a copy of it at an amplitude that we choose through you know, this effect. And so what we can just say is sig equals Gverb. And I find that Gverb is actually very loud. Like, it almost amplifies the signal. So I am going to keep this times 0.5. We'll just put it there. So, right, that's all we need to do to make this into a true auxiliary send, at least in the context of creating the synth-defs. And now down here, we free all. We'll make a source group and an effects group after the source group. And when we create our reverb, all we need to do is set the input to be reading from the correct bus and outputting to hardware. That's all fine. And the only thing we need to change is we need to also provide the bus for aux out. And out, our primary out, is now just 0. And our aux out is going to be reverb bus. And our aux amp we'll initialize that to 0, even though it's already default to 0, but initially we're just going to hear nothing. And this might be kind of loud. No, it's okay. And so now we can say source group dot set aux amp 0.1. Okay. So the last thing we probably ought to take care of is this is a mono. And, you know, I don't really particularly like sending a mono signal straight to hardware because, especially if wearing headphones, it's just the most psychologically asymmetrical thing. And so what we're going to do is we're going to stereofy this, which means we are now writing a stereo signal to these two output buses. So we need to change our reverb bus to be stereo, right? That's important. And then we also need to change our input UGen to be stereo. And Gverb, I think, it's maybe not the best choice for sort of a teaching video because I think if you send it a stereo signal, it produces a stereo signal. And if you send it a mono signal, it produces a stereo signal. At least I think so. I guess I've never really checked. Let's do this. So we'll just reboot with 4 outputs. And I just want to see if I see any activity here. So I think we're good. We're going to run this. Right? Nothing wrong with that. And we're going to run this. And so now we should hear a stereo signal. Yeah, that's good. Yeah. I want a low frequency triangle wave. I changed my mind. I'm allowed to change my mind. Okay, so this is even more elegant, I think, because now we have a true auxiliary send. The source sound, we have some amount going straight to speakers, and some amount going to an effect. And here it is. And then we send that effect also to the speakers, and then we can sort of mix between them. One thing to keep in mind is that the way we have it coded currently is that our send is post-fader, if we're going to use mixer terminology. Because if we set amp to 0, then sig becomes 0, so we get nothing here, and 0 times whatever is also nothing. So let's just confirm that. So we're going to do this. Let's bring up this. Source, what am I doing? Oh yeah, source group dot set amp 0. Right? That is a post-fader send. Here's our fader, our main amplitude. If we turn that down, with it goes the send, right? It's a post-fader send, so we hear nothing. So a good question is, how do we make this pre-fader? Well, the answer is you take this away. Don't apply that to the signal before sending out. Apply it here. So we have a separate amplitude, an amplitude for the main output and an amplitude for the auxiliary output. And so now there's no amplitude control until we actually send it out. The main output signal gets its own scaling, and the auxiliary output gets its own scaling. So now, if we run these, and then run these, which I guess is not necessary. A lot of this you can just leave running. Right, so here we go. So we can bring that up. Right? So this is now a pre-fader send. Right? The send happens before we adjust the main amplitude of the sound. So now we have just the reverberant sound, right? So we can even ramp this up, you know, and ramp it down, and then bring in the dry. Okay, so what I'd like everyone to do is to please watch tutorial 7 on YouTube, because it covers all the same stuff I covered here, but in a more succinct and prepared and clean way without code all over the place. So I hope I've sort of planted the seed for concepts here. If you watch tutorial 7, I'm optimistic that it'll sort of cement a lot of the ideas presented here. So please, 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 please go watch that video sooner rather than later. This is a tough concept to get through. I mean, it's high level stuff, definitely. We've been making all these synths and synth defs and sound functions, and we've always been doing out.ar 0. Just go straight to the speakers, no effects. You know, if there's any sort of filtering and reverb, we'll just put it right there in the synth def. But that's ultimately sort of a dead end. It's just, you're gonna run into memory problems, and it's just less flexible. I mean, you could theoretically put your entire piece in one synth def, and like that would be really crazy, and you just have no independent control over any of the effects. So this is the key word here is modularity, right? We are modularizing our synthesis processes, right? We have the source, you know, we have the effects, and so we can have different effects here and there. We can route them in series, we can route them in parallel. It's kind of like the equivalent of having a studio with a patch bay, where you have all of your equipment connected to the patch bay jacks, which you can think of as buses. And you decide, okay, you go to this bus, you read from that bus, you go here, you go there. But the advantage of something like SuperCollider is that they're digital, and so they're sort of imaginary patch bay jacks. And so you could theoretically plug something into itself, or route 1,000 different, you know, cables into one patch bay hole. So it's much simpler that way. And I've found it to be really liberating to start thinking about, yeah, you get a bus, you get a bus, everybody gets a bus. Look under your seats, a bus for everybody. I found it to be really liberating, especially when you've sort of seen the hardware studio setup, where you have, you know, effects. You have a reverb effect and a delay effect and you know, an equalizer, and then you have your mixer, which is how you can do auxiliary sends that way, and you have your computer and things. So, I mean, of course, you could go too far. You could make a synth def that only outputs an envelope, and then you have to output the envelope signal to a multiplying synth def, which then multiplies the signal by an envelope. So, you know, what we're doing here, I mean, this is just so simple to put a signal and multiply it by an envelope in a synth def. You know, you wouldn't want to make a separate synth def for like just an envelope. But for something like reverb, yeah, definitely, because then you have your reverb effect, and it's completely isolated. It can receive multiple signals from multiple synths. And if you want something to read from multiple buses, you know, you can say sig equals sig plus in.ar, you know, into another bus. So it's really, really flexible. You can put as many ins and outs in a synth def as you want. Can we basically send the aux to the bridge? Well, the bridge, you know, where we have jacks which are just wired together so that you can put one signal in and get 3 copies out, the equivalent at SuperCollider would just be creating 4 identical synths, or 10 identical synths. Then you have that same signal duplicated, and you have 10 different nodes on the server, and yeah, that would be the equivalent of a patch bay bridge, is you would just make multiple synths. Yeah, it's buses, ins, outs, server architecture. There's a lot of stuff going on here, but it's all coming from a familiar place. It's just sort of a new look. So I'm going to try to cook up some simple but robust code examples for class tomorrow. And I think the take-home problem, I'm leaning towards the first take-home problem that's basically one big problem, where it's, you have a task where you have to make these certain effects, and then you need to actually write some code which builds them on the server, instantiates them on the server, and creates sound such that it goes through effects in a particular order. And I think it'll be fun. You're basically going to be creating a little miniature virtual digital studio emulation with effects and source sounds and stuff. Yeah, I mean, what we've done here is we have our modular, our synthesizer, which is making a triangle wave, and then we, send it to a mixer, and then we can output it to one thing, output it to another thing, and route it to the reverb effect. So, yeah. That's about it. But I mean, I know I covered a lot of stuff, so I will happily hang around and take questions and paste bins and stuff if anyone's been following along. Yeah, I think Dongrule or D-Rules that's basically correct. You're just basically creating digital versions of the hardware that we have here in the studios. Here's your MIDI Verb or your Virtualizer Pro or whatever. And when we, activate it here, we're saying this is the patch bay hole. This is the jack on the patch bay that connects to the reverb effect. No, the equivalent for, so Pierre, there's a class called NDEF, and the N stands for node. So I would assume that, that is a good question, because is there a group in here anywhere? No, maybe not. Yo, I got a newsflash, David. It's all the same. I mean, SuperCollider, DAWs, and a studio with a bunch of hardware and analog equipment. The concepts are the same. As soon as you are able to get past the immediate visual layer that makes them all look completely different and seem like they act completely different, but it's all the same. It's the same terminology. It's the same design. It all comes from the same place that's been happening, that you've seen in software and hardware for decades. It's all the same concepts. There's no need to reinvent the wheel. It's all DAWs think about buses in a particular way. I don't know. I know a lot of you guys, my students, are Pro Tools users, but I know there are buses in Pro Tools, and you can, that's how you do a bus mix, right? You say these channels are going to go to these buses, and then you can have 8 tracks that read from those buses, and then you can route everything that way. Exactly the same thing. Logic Pro has buses, and you can make a bus mono or stereo, so that's a little bit different, because in SuperCollider, they're all just mono buses, but you can allocate consecutive buses for multi-channel signals. Yeah, that is a very big difference, actually, Dongrule, is that in the analog studio, order of execution does not matter. That is an inherently digital concept, and it has to do with the discrete way samples are processed. There's an order, there's everything like that. But so in SuperCollider, you can feed signals back into themselves. You can create a local feedback loop, but there is always going to be at least a 1 sample delay. You can get that down to 1 sample, and you can feed back every single sample. You have to change the control block length to 1 sample, so you're basically running everything at the audio rate. But even then, it's a single sample, and that is a non-insignificant amount of time compared to the analog world, where if you take a mixer and you just feed it back into itself, that's moving at the speed of light. So that's real feedback. So it is a little bit different. Yeah, you do not have p-binds in Pro Tools or Logic or anything for that matter. So yeah, SuperCollider has got some advantages there. Yeah, I agree. I think SuperCollider does a lot of things nothing else can do. There's tons of languages out there. I mean, well, there's Max MSP, there's C Sound, there's Chuck, there's Kima, there's Sonic Pi. There's all sorts of stuff, and they're all different, and they all have strengths and weaknesses. From a very sort of general perspective, yeah, they can do everything, for the most part. But some things I think it's a little bit faster in some programs to do. Like for example, multi-channel expansion in SuperCollider, the ability to just take anything and just say, by the way, give me 1,000 of those, and there you go. You have 1,000 ones, and this is equivalent to polyphony on the server, and I don't think C Sound or Max MSP have a good way of doing this. I mean, there's the poly object in Max MSP, but that's I don't know. It's a little bit clunkier than I think most people would like it to be. That's just my personal opinion, though. Yeah, Locust. That's totally right. I mean, you want to patch things in the correct order, and when you patch at the patch bay, you are determining the order in which things happen. I mean, you definitely cannot plug. You wouldn't want to plug a signal into the outputs of something, which is something you can do, and that's generally not good for equipment. But yeah, it's order of execution and making sure things go in the right order is exactly the same concept as patching correctly at an analog patch bay. Yeah, and I agree, Spacetime. I mean, that's all DAWs are modeled after. It's basically, I like to think of a DAW as if a multi-track tape deck and analog mixer had a digital baby, and that would be the DAW, where it is very linear, right? You do play from beginning to end, but and that's really useful, especially if you want to make very, very, very fine adjustments to your audio and make everything sort of very, very perfect, and then play it and it's the same every time. And SuperCollider can do that, but it's more work because it's a programming language and you can't see the audio you're working with. You can't physically grab a segment of audio and move it and copy it. It's just a completely different environment. Speakers last. That's right. Output bus 0 is at the end of the chain. Right. I'm trying to think if I missed anything really important. Oh well, you can. Okay. Let's say s.options.num audio bus channels. Right. Now it went to 118 again. I know that the default value for number of audio bus channels used to be 128, I think. Now it's 1024. This is actually really puzzling. This might be a bug. I really don't know. But I do want to point out that you can change the number of audio bus channels. You can say, give me 2048 and reboot. R.reboot, s.reboot. And now we have 2048. So you can make more channels. There's got to be a limit somewhere, but I actually don't. I don't actually know where that limit is. But and generally speaking, 1024. That's plenty. And by default, the number of control buses. Remember, we have out.kr, and we can pass control signals from one synth to another. The default here is 16,384. So a lot of buses. My Twitter, I did do an Arduino project. Yeah, it's ongoing. It's actually on my desk back there. I think you're probably talking about this. It's a bunch of Arduino board or breadboards all snapped together, and there's 256 photo resistors in a 16 by 16 grid. Right now I have 5 out of 16 rows completed and wired to multiplexers. And it's basically just a big light sensitive controller. So I get, a 10-bit value from each photocell, and the Arduino just puts those into a giant array and passes it over USB to to SuperCollider, and then yeah, so it goes to SuperCollider, and ultimately it's going to be a sound controller that is light sensitive. Yeah, there's one video on my YouTube page where it makes sound, where I just do like a little 16-note arpeggio, where if I put any of the photocells in shadow, they produce a little note. And yeah, that's basically the project. I'm currently working on a piece for wind controller, and that's sort of taking up most of my time because that's more pressing, because the premiere is going to be like in November. Yeah, no problem. Thanks for asking. All right, so to reiterate, this is server architecture, and I just want to encourage everyone to, in addition to rewatching this video, if you find that useful, also go to my YouTube channel and look at tutorial number 7. That is my server architecture tutorial, and I think it has stood the test of time pretty well. It's still accurate. I mean, there's some things where you'll see the defaults are maybe different, like the number of input and output buses are 8 instead of 2, but all the concepts are the same, and I do something similar. So yeah, this has really changed the way that I use SuperCollider, knowing this kind of stuff. I would like to, just for fun, let me bring up the piece that I'm working on. And I'm not going to play any sound because I have no idea if this is going to work. But let's see if I run this. I just want to show you the node tree and how my sort of workflow. And let's bring up the node tree. Yes, okay. So here's my node tree. I have a bunch of groups at the top. I have 3 groups, and then the top group actually has 3 subgroups. And then scrolling down, I have a group which is basically a local feedback synth. So you can feed it a signal, and you can cycle it back. So you have sort of an infinite echo. And then I have a few, these say delay. I have a few delay synths, 2 different reverb synths, and at the end I have a compressor, just because a little bit of light compression. I'm not doing any limiting or hard compression, just enough so that I can get a little bit careless with my levels and not have to be constantly micromanaging everything. But so as you can see, I'm following what I preach here. I make groups and I name them. Let's see if I can find my groups here. Yeah, here's where I make my nodes. I have a function called make nodes, and here I make my group. I create the 3 subgroups and put them in that group, and then we have local feedback group, delay group, and they all just go after the one before it. And I also make a bunch of synths, and I put them in the correct group. All the delay synths go in the delay group. The reverb synth goes in the reverb group. And oh, where are my buses? Let's find my bus. Yeah. So what I do is I make a dictionary, and I add audio buses to that dictionary at individual keys. So after I do that, I can say stuff like bus at reverb 1, and this returns that particular bus. Or I can say bus at delay 3. This is the bus that I would write a signal if I want it to get sent to the delay 3 synth. And you can see they all have their indices and stuff like that. So much larger scale, but the concepts are all the same. We make buses, we make groups, and then we put synths in those groups. And that's, that's kind of all there is to it. So anyway, I think I'm going to wrap up here. I'll have little in-class exercises for everyone to do tomorrow. If you can squeeze it in before class tomorrow, I really hope you guys can watch tutorial 7. I know I keep ranting and raving about it, but it's not that long. I think it's like less than 20 minutes. It might even be like 15 minutes. I can't remember, but it's I think it's pretty to the point. Yeah, well, thanks for watching, Pierre. And yes, and Parmar, feel free to ask homework questions here. I'm totally happy to do that. Sometimes I feel like I should start the stream like 15 minutes early to take homework questions then as well. So yeah, you can paste bin something to me, and I'll take a look at it on stream. Make a MIDI controller with a Pi. Any ideas? I got a Pi here. Maybe this, one of these. Gosh, I don't know. I mean, I guess you would probably get some, resistors, some potentiometers, like knobs and faders, and breadboard them together so that you have, I don't know, you got to figure out the design first of all. How many faders do you want? How many knobs, or what kind of interface do you want? And then you've got to, trigger pads. You mean like those pressure sensitive pads? Yeah, you'd have to acquire some of those somehow. I mean, you can get force sensors, so that would probably be the best thing. You can look into like force sensors on sparkfun.com or adafruit.com. Oh, the code side of it. Well, does it have to be MIDI? I mean, why? I mean, I guess if you want to control some, MIDI synthesizer, it's, I mean, I make stuff like that. I have sensor gloves, and I've got this, this 16 by 16 grid of photocells, but there's no MIDI involved. I mean, it's just electricity. It's just sensors, and they have a voltage, and then I use an Arduino to digitize those voltages and then send them to SuperCollider, and then I can do whatever I want. I mean, the whole point of MIDI is to make sound. I mean, and other things, but MIDI as itself is just data. So I don't know if you need to be married to the MIDI idea or anything. Okay, let's take a look at this paste bin. All right, so we have, and of course this isn't going to work for me, so maybe I can find my drum loop one. I have a drum loop somewhere. My dang drum loop. Let's see, maybe it's on, let me download it real quick. Spring. No. Loop one. Okay. There's my drum loop. So I'm just going to, first of all, just change the path to be something which just works on my computer. So let's boot the server, and we're gonna let's hang on. I have a bunch of stuff left over from when I opened my piece. Server tree dot remove all, server boot dot remove all, or quit dot remove all. Okay, so now let's boot the server, read this, read that, and why don't we close this wacky thing here? So first of all, I like to check to make sure. I think this is stereo. Okay, that's working. So nothing is playing. Synth drums. Oh, well, out.kr is not right. You want out.ar, right? See if that works. Something else is wrong. Okay, let's back up. Sig equals playbuff.kr. That's wrong. So this is an audio signal, right? We're playing an audio file, so this has to be AR. This is a control modulating. Yeah, they're all KR. Some of them can be KR. This can be KR. That's totally fine. And then, this one has to be AR because its input is this audio signal here. And this has to be AR as well. Yeah, so you weren't getting any error messages because you were being very consistent with your KRs. They were all KR, and so the server was just like, okay, this must be a control rate synth through and through. So now I'm just gonna let's just multiply this to be safe by 0.2. Yeah, that's working. So we can do this. It's a little loud. Let's do this. And I'm also going to make this all the way up to 10,000. So that's working. The difference between AR and KR is that AR is 44,100 samples per second. KR is one sample per every control block, which is 64 audio samples. And I think you just can't do this. You just can't. I mean, this is our sound. This is what's going to go to our digital to analog converter and go to our speakers. So if it's a sound, something we're going to listen to, it has to be AR. You can't. I mean, you can. If we do this, I think what happens is it plays this. SuperCollider plays this signal on the 0th control rate bus. That's not this bus here. It is not this bus. It's some internal control bus. Control buses are all internal. So if you do this, I think it makes a signal, maybe, but it's not playing on the correct bus. We need to play it on the 0th audio bus. Yeah. No. This is the whole point. It's one of the points of doing a live lecture online, because I'm trying to sort of merge my internet presence with my teaching presence. Everyone is welcome. It's just that I can't take constant questions or anything like that. I mean, this is just a 2-hour thing, so actually probably a lot of my students have checked out already, and they're probably gone to bed. So yeah, it's class is over. Now I'm just goofing around on the internet. Yeah, it would be interesting. I mean, I think this generates a control signal, but if we do out.kr, we won't hear anything because it goes to a control bus. And yeah, these are audio buses. Does that make sense, Parmar? What I'm getting at here? Yeah, they're not interchangeable. When you're talking about stuff you want to listen to, that you want to turn into vibrations in the air and have them seep into your brain, you just have to use AR. Cool. Yeah, but this one, for example, that's okay if that's KR. In fact, I think it has to be KR. I don't know if SuperCollider is able to convert the mouse position into an audio rate signal. Yeah, KR is the only one here. So yeah, and also in general, it's okay for that to be a control rate signal because it's modulating or controlling the cutoff frequency, and that's not going to be zipping around at 10,000 hertz. It's going to be moving pretty slowly, just at the speed of the mouse. So yeah. Yeah, I've noticed. I've sort of poked around on the music community a little bit, and people are, I guess, mostly songwriters and like electronic music producers, and yeah, I know I'm kind of a weird case here, but yeah, this is what I do. So SuperCollider is an audio programming language for real-time audio synthesis and algorithmic composition. You can just go to supercollider.github.io, I think is the website. Oops. Yeah, I know I can only open one copy of Firefox at a time. Yeah, so you can read about it here and download it. It's free. It's open source, and it's cross-platform. And I use it for a lot of stuff. And I've used it so much that I've decided that I'm going to teach a class on it here at the University of Illinois. Native, you mean talk about native instrument blocks? I don't know what you're talking about exactly. NI blocks. Yeah, I mean, I know Native Instrument, the company. I know some of their products, but I don't know what NI blocks are. I would guess like control blocks, sample blocks. I don't know. I mean, you know, blocks of audio, it's a common concept through a lot of different types of audio software. Oh, okay. Yeah. Yeah, that's right. Okay. And I think I remember it kind of reminds me of like how Ableton incorporated Max for Live so that you can actually build little Max MSP synthesis modules and you know code them in the Max MSP language and then like drop them into Ableton as like an effect on a track or something. Yeah, coding's cool. I mean, I once I got the hang of this, it's basically like all I do. It's basically all I do as far as audio goes. I sort of compose all my pieces in here. I still use DAWs, you know, but less so. I mean, just for quick and dirty stuff. I like to, yeah, I like to get my hands dirty with SuperCollider though. All right. Okay. So it's getting kind of late for me, and I should probably head home. But at least for this semester up until you know early December. So I'm gonna be streaming every Wednesday night for me, 8 p.m. Central Time. So you can catch me here again next week. So yeah, you have a great night as well. Thanks for chatting. Thanks for stopping by. Thanks everybody for watching, and I'll see you all next week for more SuperCollider. So take care. Have a good night.